Okay, so we're back. While I was working today, I'm a student, but I call it work because I should try to treat it seriously. But in any case, while I was working today, I had some thoughts for the permutation program. And so even though yesterday I said, oh, I shouldn't do these during the week at night, I really wanted to do it again today. So let's go ahead and get started. By the way, I looked at my last video. I realized that I never remembered to make the text bigger on the screen, so it was kind of hard to see. So I'll remember to do that now. Okay. So I made a quick list of ideas. First things first, I finally decided to make the switch to the other permutation notation, or representation, I should say. Right now I'm using like a cycle representation, right, where I keep a list of the positions and where the cycles start and end. But I just realized that by the way, so I was thinking about changing it to the tabular representation of permutations, which I talked about extensively in the last video for way longer than I had to, so I'm not going to say it again. It was the part with where I was drawing dots and lines in MS Paint. But anyway, I was thinking, oh, well, if I want to do the tabular one, then I'm going to have to write a constructor to build the tabular one, and then I realized something. That is exactly what looking for it. This one does. This function here. Oh wait, no it's not. Hold on. 1 second. Yeah, it is exactly what this does. No, wait. Hold on. No, that's, sorry. No, I got this. I got this. It's not that one. It's not this one. It's the multiplication. This multiplication converts the cycle representation into the table representation, which I actually bothered to compute in this cur vector, which I sort of had forgotten about. So here, instead of, I could just take this code, right, and take away the stuff for the second factor in the multiplication, second product, and make that the constructor based on strings, right? That's the general idea. Okay, that was the first idea, is changing the internal representation. The next idea is that, hold on, I have them written down here. Yeah, so one of the reasons why I was unsure about the tabular representation is because what if I, maybe I should just always have Paint open. Talking about it's always hard to understand. Okay, so let's say I have one permutation, 1, 2, 4. All right, and this is in one namespace, okay? So like every permutation has a namespace which converts the strings. So I guess oh yeah, that's right, I'm in MS Paint. I don't know why I'm erasing when I could have selected and deleted, but I've already started. Okay, let me restart that discussion. So let's say I had a permutation A, Bob, and Cat or something, okay? So this, I call it the namespace, this nmap, okay? It is what stores this map from a string to an int, and it converts this to our internal representation, which in this case would be 0, 1, 2 if it was the first permutation that was constructed using this namespace. But when we construct a new permutation later and add it to this namespace, maybe it's something like a cat and dog or something like that, then now the namespace grows, and this permutation is would be represented internally as, oh, so I'm writing it in cycle notation again. Okay. I'll change this one. I'll fix this one. This would be represented internally as 0. And wait, hold on. It would be represented as A, which is the first one, goes to cat. All right, so that would be 2. Then Bob doesn't move. Bob stays where Bob is. Cat goes to dog, okay, and dog goes to A. This is kind of ridiculous, but you get the idea. This one here, I did it wrong. I'll just put that off to the side to remind us of our bad error. It's almost right. This would be represented internally as 0. 0 goes, oh no, hold on. A goes to Bob, so that means 0 goes to 1, Bob goes to cat, so 1 goes to 2, and cat goes to A, which means 1 goes to 2 and 2 goes to 0, okay? So now it kind of looks like there's a problem now, because this one doesn't say where to put 4, which is also, dog. But actually, that's not a problem. If this permutation was made before the namespace grew, we could, this is not what I'm planning to do, but we could go back and just add the 3 onto each and every one of them, all the ones that were built before the namespace was expanded. Or we could just not and assume it's there. So any algorithms that we write, if the vector is shorter than it should be, that is to say, the length of the table is less than the number of elements in the namespace, we'll just assume, we'll write the algorithm assuming that anything past the edge of the vector is has the property, I shouldn't use A here, where the vector at position I is just equal to I, as in it doesn't move these elements, and obviously it doesn't, okay? Okay, so that was the second idea. Let me just fix everything. The third idea, yes, in our output function here, we build this inverse each and every time we output the data. But actually, there's no reason why we couldn't just maintain this inside of the nmap class. It's actually very simple. Every time we add a new pair, key value pair in the map, well, we just append a pointer to the inserted string into this vector. That's all we have to do is just append it to the end. It's actually pretty easy. So that's the third idea, is having the nmap class also maintain the reverse lookup. Okay. Now, it is kind of late, it's 10 already, but we'll see how much I can accomplish. I'd like to accomplish at least 2 out of 3 of these ideas, and if I do them really quick, we can move on to doing the orbits. Yeah. Okay. Briefly before I start, I don't know if anybody's watching this video. Maybe I'm the only other person who's ever going to go and look at this. But I've been doing these for fun, but today was just kind of a bad day where I was just being reminded over and over and over that, I'm not like a world-class expert on anything. I don't know how to explain it. It's like, have you ever seen this curve on the internet? What do they call it? The knowledge versus how smart you feel. I don't know why I'm looking it up when I could just draw it. And now I'm letting everybody know how slow my internet is. What is this? Okay, it's kind of close, but no. Basically, on this axis, it's how smart you think you are. And this is actual knowledge, right? You've all seen this before. But basically, like, you know, you start maybe, you don't think you're an idiot, but you don't think you're an expert. Then you learn like one thing and you think you're king of the world. You learn a few more things and you're like, oh yeah, I'm really good at this. And then you start learning more and you're like, oh, there's more to this than I thought. Oh wow, I really don't know anything, do I? And then it's a slow climb up to becoming a real expert. Basically, everything that happened to me today, it has been like pushing me down that way. And like, at some point, I'm doing a master's right now. At some point, that's going to be over, right? And I keep saying that I don't want to stay in school. I want to go out and work. Then I think to myself, what proof does anybody have that I have any, you know, skills? Oh yeah, masters, whatever. That's not work skills. Like, I don't know how to develop a website. So I realized that these videos I've been doing is kind of like my way of A, you know, learning some skills, and B, proving to people that I have them. So I'm hoping that this will be worth doing. Okay, I don't want to say any more of that. Time to get started. If I'm talking to myself in the future, well, I'm sure everything's fine. If I'm talking to random people on the internet, I don't know why you're bothering to listen. Oh, this is wrong. This should be a 3. Okay. The first idea is the hardest to do. Let's do the third idea. That one's the easiest. Let's put this in. And it's very simple. We don't just increase this. We also do rev lookup dot push back, and we do the iterator arrow first, and we want the address of that, and that's it. I think it should be. I'm thinking. Okay, now the next thing to do is to edit this function to not do this. One thing we could do, which would be really slick, actually, is I was thinking about doing an operator overload, but you know, let's say I do, you know, operator, right? One of them would return a string, not a strong, a string, given an int. The other one would return an int, given a string, right? This one would just use this one's. You know what? I don't like this. I don't like this type def. I'm getting rid of it. It's just confusing. There. So one of them would just use the maps index operator, and then if I ask it for an int, it would overload and use the index operator for this guy. Except these permutations, they store pointers to these nmaps. So I don't... What happened here? Hold on. I lost the function that I spent so long writing. I can redo that, that's easy. Is that it? Is that back? Okay, I accidentally deleted it. All right, let's just quickly go and do this. Oh, whoops. Okay. There. Okay. And then we go in here, get rid of that. Don't want that. Yeah, so here, I don't think you can do p arrow names. Oh, maybe you can do that. You know what? Let's try it. It would be really slick. Maybe this should be a reference. Is that what map returns? I mean, if that's what map returns, then that's what I'll do. Oh yeah, look at that. Okay, fine, we can do that. So it actually returns a string reference. And takes an int, and this is dead simple. It's just return names. Oh, sorry, rev lookup of, and then this one is an int. Now, is this doing any unnecessary copies? Maybe. Maybe I should make this a const ref. Okay, so let's try that. Yeah, I figured as much. Okay, let's see what we can do. Yeah. Actually, the thing to do here . There. Oh. Okay. Push back. Pointer to. I'm not sure what that's about actually. To pointer to this funny type. Oh, const. Oh. Yeah, it doesn't like it because it's const. Well, we can make it const. Why not? Oh, but then we gotta go in here and make this a const ref. Dereference. Ooh, we're almost there. Oh yeah, okay, I knew something was wrong. I don't think you can do this like that. Yeah. But it's still not too bad to do this. unused variable. Oh yeah, wait, that's the function I started writing the other day, and I was just 2 out of it. I can't tell if it's working because I'm using numbers in here. A, and let's make this C. Make this F. Sure, that's probably good enough to do a quick test. And you know, let's make this one Charlie or something. Yeah, I think we're okay. Okay, so idea 3 done. Of the ones that are left. Idea 2 is, yeah, that's right. Okay. We'll get there. Idea 1 is now we are no longer going to do this vector of int data, vector of int cycles. No. I may keep this bool inverted actually. But no, we are going to just simply do vector of int, and I'm going to call this mapped. This is basically what we have. If I do, no, maybe I should call this. It's like, I'm thinking like new position of, so that when I type it in code, it would be new position of I, right? But I think mapped is fine, or maybe mapping. I think mapping is fine. Okay. So these are just delegating constructors. Okay. Yeah, so the technique that I had in mind was to take this. Let's copy it in. Let's see where we at. Sorry, it is a bit late. And I had a pretty difficult day. But we're going to do this. Okay, let's just get rid of all that. Also, we don't need to check for inversions. All right, let's see how this looks. We need to iterate through each cycle backwards, maybe. Excuse me. Okay. Can you pause recordings? No. Fine, I'll just power through and do it. I can do this. Oh, it's hard to stir up the juices. All right, let's close this. Let's think about it here. So, okay, let's, you know what? This is what we're gonna do. We are going to comment that out and use it for reference, but we're just gonna write it from scratch. I think that'll be the easiest way. So, Okay, I want to iterate backwards, so let's do that. Let's start with that. Equals p dot size minus 1. I think what I'm going to do, by the way, is look up what the laws or whatever are about having music playing in one of your videos. Not that it matters. What am I going to get? Like one view from one guy like in India or something who finds this by accident and closes it 20 seconds later, you know. But anyway. I is greater than or equal to 0, I minus. Okay. If p. So we check if Oh, I see it. I see exactly what I gotta do. I see what I gotta do. Yeah. Let's get rid of all of... Okay, we can keep this. Yeah. Okay, I can put this back. Okay. I know, we do have to keep this. We do have to keep this because this is all the hard work we did to actually parse the strings. And I don't want to redo that. And actually, now we can just take this code. And the beauty of it then is now we just do vector of int data, vector of int cycles. And pushes the size of data to the end of cycles. Yes. Yeah. Okay, great. And now I got lost in my code. Let me close some stuff here. I don't need this if other inverted. De-indent this. And I also don't need to make a new vector. I'm just going to use this one's vector. So mapping, which is a vector of int of size, names arrow, arrow n, and instead of cur it is mapping. So it's not other, get rid of that crap. No, none of that, none of that. And that's it. Oh yeah, I gotta change cur to mapping. Okay. Okay. I knew I was missing one. I felt it in my bones. Okay, so we're done that. But now all the code that we wrote is no longer going to work because this is now different. So let's go ahead and fix the rest of it. Oh, something's wrong. I'm missing a... Okay, no, I'm not. I was just confused. Hey, wait a minute. Wait, what? Okay, this should fold between line 83 and line 120. It's just folding too much. That's what confused me. Weird. Okay, that's bizarre. That probably means that I'm missing a curly brace somewhere and I just don't know it yet. Okay, what's the other one? There's this one. Oh, yeah. So now this one here, this one here. I think all we really have to do is just do mapping of V, and then we can get rid of all this. But this code I think is going to come in handy. So for now, I'm just going to comment it out. I'm not sure how I'm going to use this yet, but I have the feeling it's going to come in really handy. Yes, you know what? We're going to need this when we do pretty printing. This commented code will eventually get used for pretty printing. Okay. Now, this multiplication operator, we have already taken all the stuff in here that we need. Okay, I'm just going to do you know what? I should be using Git for this. Let's do that before it's too late. Let's see if I can remember how to do it. Okay. Let's save this. Shoot. I always forget how to do this. Yeah. Okay. Now that we have a Git repository, we can be a little bit less afraid of deleting stuff. So, yeah, all of this must go, all of it. Well, except for the first line, actually. Okay, now, let's not overthink this. This should be easy. I'm overthinking it, aren't I? I'm using the word overthinking here with impunity, but I define overthinking in a different way than most people do. Some people think that overthinking means someone who's trying to be smart and do stuff in a clever way when a simple way would suffice. Yeah, it could mean that. Usually when people tell me I'm overthinking, I'm not doing that. What's happening is that I'm not thinking enough. It seems weird to say that. What I mean by that is, if I was thinking more and thinking clearer, I would be able to see the simple way. Do you see what I mean? Because I'm not thinking clearly, I can't see a simple way, so I'm fighting through the complicated way. So to do this a simple way, I think the easy thing to do is just draw it. So let's say that our namespace is, I'll draw it as JavaScript object notation. Like this. So we have A, which maps to 0, same examples before. Bob. Oh wait, how do you do this? it's key value pairs, okay? Like, I'm still overthinking it, aren't I? Charlie, that's the 2, and I don't want that. Let's put it back to what it is, which was cat. And we had what? David? No, it was dog. 3, like that. Okay, this is our namespace. Ugh. Yeah, right. You can't do that. And we're multiplying. Let's say we're multiplying 0, 2 times. That would never exist, 0, 2. So we would have it 0, 2, 1 like that times 1, 2, 3, 0. If we were, so this is the mapping notation, but I find it easier to understand permutations in the cycle notation. So this means 0 goes to 0, it doesn't move. 1 goes to 2, and 2 goes to 1. That one means 0 goes to 1, which goes to 2, which goes to 3, which goes to 0. Okay, so that's what that means. Now here, you know what? Let's add an extra one here. What's the interesting thing that starts with E? Ear. No. Elect. Elmer. Sure, Elmer. Okay. Actually, I guess the namespace doesn't matter. Okay, so let's say we're multiplying these two permutations, okay? But the namespace is actually bigger than both, and they're not the same size, right? This permutation was created when there were only 3 things in the namespace. This one was created when there were only 4 things in the namespace, and now there are 5. Okay. So I think that the result should be as large as the biggest of the two. No need to make it bigger. And yeah, okay, so let's start with that. So vector of int new tab and it's going to be, okay, so int new size. Oh, let me think. Okay. Perm pointer smaller, pointer larger. I probably have to make this const to be able to get away with this. And thinking. Then we'll do int I don't know what to call these. N smaller and N larger. Sure, that's fine. It's fine. Okay, it's fine. Now we're gonna do if man, I'm having such a hard time with this tonight, but I'm gonna power through. This is important to me. Like, if this is almost determining my future. If I can't even do this, what can I do in this life? Okay, I didn't mean to get that fatalistic. Let's move on. Okay, if, what is it called? What did I call it? Mapping. If this mapping dot size is strictly less than other dot mapping dot size, then smaller equals this, larger equals address of other, and smaller hopefully the compiler is smart enough to not evaluate this function twice. And n larger equals other dot mapping dot size. All right, see the idea? Okay. So now we're in business. Now we can just do the algorithm. So new tab of n larger iota of begin new tab and new tab. Now for int I equals 0, I is less than n smaller, I plus plus. I don't need to do the iota call, I don't think. New tab. For each I want to know where does it go, right? You know what? I should call this new mapping. Is equal to, oh, we really have to be careful about order of operations here. Permutation multiplication is not commutative. Ah, darn. Darn. Wait a minute. Yeah, it's not, yeah. Okay. This is ugly. It's getting ugly. So we actually forget that crap. Forget all of this. Special case the entire function. So new mapping of I is equal to, so when I do this one times this one, I'm thinking of it as 1 goes to 0. Oh, sorry, 0 goes to 0, which goes to 1, right? One goes to 2, which goes to 3. 2 goes to 1, which goes to 2. 3 goes to 3, which goes to 0. So how do we do that? It's the mapping it is other dot mapping of mapping of I. Makes sense? Right? First, we look inside the mapping. Say 1 goes to 2. Then we look in the other mapping at 2, which goes to 3. 1 goes to 2 goes to 3. Okay? Yeah? Makes sense. This is not the most efficient code, but it's still better than the other one, actually, probably, most likely. Yeah. So the only difference between these two is that here we switch, whoops, no, that was right, is we switch these. I don't know how to pause the OBS recording. I have to step out for 2 minutes, so I don't know. Let me find something interesting to put on the video. I don't know. What? That's bullshit. Sure. Enjoy that. Okay, enjoy that first. Okay. Okay. So I'm pretty sure this works. Oh yeah, we do need to return a perm object. So let's do that. Return perm of names. Let me check the constructor. Names. Where's that? Yeah, names vector. Yeah. And new mapping. Okay. We're getting there. That's fine. That is sure fine. All right, let's see what we have for compiler errors. Oh my god. Yeah, we don't need that anymore. Oh yeah, look at that. That's really neat. The identity permutation will have this. Oh yeah, beauty. Beauty. All right, let's work through these errors. Oh yeah, this is easy. This is easy. P dot mapping dot size. Yeah, look at that. Nothing could be easier, all right? Things are starting to, okay, and then the pretty printing function. That's, oh, this is still throwing an error. Yeah, okay. have to do this. Okay. That's just a warning, but let's get rid of it. Ah, yes. I only want to construct it once. So we can do this. Which library is that in? Numeric? I think I already have numeric. Algorithm. Oh, okay, I have algorithm. Shoot, now I'm lost. Equals max of mapping dot size and other dot mapping dot size. And it might complain about signed and unsigned types. Oh, okay. Oh yeah, there it is. Pain in the butt. Hate those warnings. Yes, right, obviously. Oh yeah, today's the summer solstice. I'm listening to the radio right now, and Rich Turfry just said so. Okay. Comparison between side. We're getting there, we're getting there, we're getting there. Value computed is not used. Oh yeah, we're getting there. Okay, and then I think the thing left is the pretty printer function. And yeah, this we will do this shortly, maybe tonight. Okay, so remember that code that I said we were gonna need? Yeah, let's grab that. Is this still... Oh hey, that seems to have fixed it. I guess the comment was throwing it off. Okay, this one is probably going to be the trickiest to write. So, okay, let's paste that code in as a comment. Let's get rid of this. I'm almost tempted to comment it. What's in here? All right, let's just put it in the comment. All right, and let's put this back the way it was for now. We'll make a nicer pretty print function in a second. Okay, let's see if we broke anything. Oh, is that correct? I have no idea. This is why I needed a pretty printer. Okay, let's just quickly push that. What time is it? Almost 10 to 11. I've actually done the third idea and the first idea and the second idea. Yeah. Okay, I've done all my ideas. The only thing left to do is update the pretty printing function to use the new representation. And we may now want to sort them by their string representation as opposed to the internal integer that they map to. Okay. Wait, did I say 10 to 11? Oh my god. Wait. Wow. Okay. In any case, the orbits function. Yeah. All right, let's just do the pretty printer and let's save the orbit function for next time. I can probably knock it out pretty quickly tomorrow, maybe even tomorrow. Tomorrow's Saturday, by the way. Maybe tomorrow I'll be able to do an implementation of finding the stabilizer of an element. I'm mostly saying that for my own reference. You know what? Maybe tomorrow I'll do a video explaining the group theory behind what I'm doing, and I should be able to do the orbit function as an example to illustrate some of the ideas. That should be pretty good. Okay, let's finish the pretty printer and call it a night. Okay. Let's see what we got. We don't need this. I don't even know what this is. Okay, so we start by doing O gets a open paren. So here, instead of pushing back into the data vector, we will do O. Oh, this isn't going to sort them though. Not going to sort them. You know what? It's fine for now. Okay, it's fine for now if they're not sorted. Right? Let's just start with this. This is what I want to finish tonight. Maybe we'll think about sorting after we get this working. Okay, so here instead we're going to do O P names of pause, like that. And in here, instead of cycles.pushback, we're going to do O like that. Now, to start a new group, when a group finishes, yeah, check this out. Check that out. Ah, beauty, beauty. And then, we don't need any of this junk. We just do the last close paren, and this is from the French keyword that happens sometimes. Names is not declared in the scope. While pause is less than. We can do this. That's pretty slick. Okay. Error, no match for operator equals. That's weird. And get rid of that warning. That'll drive me crazy. This is weird. Maybe it's an order of operations thing. Oh yeah, we're getting there. We are getting there. Operand types are const. Shared pointer. How did I do this before? I did this before, didn't I? Oh, yeah. Order of operations. Alright, cross your fingers. Hey, ooh, commas, need commas. Oh, shoot, but we don't want commas after each one. Gross. Damn, thought I would get away with it. I'm doing shotgun debugging. Oh yeah, we have some extra right brackets. But always at the end, so maybe we can just do this. This last permutation has order 15. So let's see what happens when we raise it to the power of 15. I should do the times equals operator soon. So now that should be the identity permutation. There are easier ways to do it, but I thought this would be interesting. Maybe I miscounted. 1, 2, 3, 4, 5. 1, 2, 3. The order should be 15. This is squared it to the power of 4. Oh, this is to the power of 16. Yeah. close. All right, let's do it the dumb way. I don't know why my window is scrolled over. There, fixed. All right, let's see if it was just an off by one error or something. Okay, so the identity permutation doesn't print anything. That's not what we want. We want it to print the empty parentheses. So let's go take a look at the pretty printer. Yeah. There. Oh, yeah. Right, because the size isn't 0. It's like 8 or something. But they're all mapping to the... All right, I mean, this doesn't have to be super elegant and fast. So we can do bool wrote something equals false. And then here, this is the only thing that writes, well, if it gets here, it wrote something, so wrote something equals true. This is kind of messy code, but whatever. If we did not write something, okay, beauty, beauty. Yeah. Yeah. It's 11. I think I better end for tonight. I better not push my luck. This was a productive one, so git add dash u, git dash m, finished converting to new regime. Tomorrow we will we'll talk about the group theory. We'll write the orbits function, and maybe we'll generate, or we'll find the generators of the stabilizer subgroup. Okay, I feel good about it. I feel better. I feel better. Yeah, today was not a good day, but doing something productive kind of helped. Although now I'm wicked tired, so I'm probably gonna sleep well. Okay, bye-bye.